Section 2.9 is about the quotient rule. So this is a way of figuring out the derivative if your function is a quotient of two other functions. It's like the product rule, it's more complicated than just taking the derivative of the numerator and the denominator separately. So this is the quotient rule. If your function is a quotient of two functions, then the derivative is this big ugly mess. There's a poem that helps you remember the quotient rule, and to be honest with you, I never use the quotient rule without the poem. So here's what the poem is. It says low, which is short for denominator, d, which is short for derivative, high, which is short for numerator, minus high, d, low. Let's go over that again. Low, d high, minus high, d low, all over the square of what's below, and away we go. So the purpose of the poem is, in this case, unlike in the product rule, it matters what order you take your derivatives in and what order you do your work in, because it's subtraction. So if you go in the wrong order, you'll have the wrong sign. So the poem helps you remember what order to do your derivatives in. It's low d high minus high d low, all over the square of what's below. And if you accidentally do high d low minus low d high, your poem doesn't rhyme. So it's wrong. I'm not going to prove the quotient rule. It's maybe just not worth our time. But the quotient rule, if I were going to prove it, I would probably go back to the definition of derivative and go through that process, but it might not be fun. Alright, so how can you use the quotient rule to solve a derivative? Well, let's go through this one. If you feel confident that you can try it, or if you just want to try it, please pause and then do it on your own. Come back after you have given it a shot. Alright, so I'm taking the derivative, so dy dx is the notation for derivative. My dog is here to help. And so it would be low d high minus high d low all over the square of what's below. And then in this particular case, I often see kids try to say, oh, well, I have a squared here and a fourth here, so I can cancel. But you can't because there's subtraction. You can cancel if you can turn it into multiplication. So if you can factor something out of the numerator, which we can get an x out of the numerator, then we can cancel. But we can't just cancel through subtraction like that. So now we can cancel one of our x's, so we wind up with x cosine x minus 2 sine x over x to the third. That's about as good as it's going to get. If I knew x, I could easily plug it in and come up with an answer. I just really want to stress that this answer is totally acceptable as long as you're not trying to find a multiple choice. And I really want to warn against doing some algebra incorrectly. So I wanted to show you how to simplify it, although your answers don't have to be simplified for my test unless it's multiple choice. Hi, Roma. Back off, please. All right, we're going to do a tangent line equation, so we're going to use the quotient rule. I would recommend pausing and restarting after you have tried this problem on your own. All right, so to write a tangent line, I need three things. I need an x-coordinate, x is e. I need a y-coordinate, that's going to be f of e, so natural log of e is 1, and 1 over e. And then I need a slope. The slope is going to be the derivative, so that's my next step, so I'm going to take a derivative. So low d high minus high d low all over the square of what's below. And so if I do, and actually I'm not even going to worry about simplifying because it's time to plug in e, although I notice these x's cancel, so that makes my life a little easier. So I have 1 minus natural log of e all over e squared. You don't have to do arithmetic for the College Board, but natural log of e is not arithmetic. Natural log of e is more like algebra, so you do have to know how to do natural logs. And this natural log of e is what's the exponent of e that gives you e, so that would be 1. And so we have 1 minus 1 over e squared, which means that the slope of the tangent line is 0. All right, so I have a horizontal tangent line at x equals e. So the equation for the horizontal tangent line would be y equals 1 over e, because the slope is 0. All right, this is an extension problem because it involves a calculator. I just want to make sure that you're comfortable with calculator problems. For what value of x does the tangent line have a slope of 2? What I would expect you to do for this problem, which is a calculator active problem, is first I would expect you to find the derivative yourself. So I would expect you to say, well, f prime of x is equal to low d high minus high d low all over the square of what's below. And then once you have that, you don't really have to simplify that any more than that. You can, but you don't really have to. You need to grab a calculator. And for the College Board, what you would say is, I'm trying to find when is that mess equal to 2. So I'm trying to find out when is the square root of x times e to the x minus e to the x over 2 root x all over x equal to 2. Now you grab your machine, you graph, and you find your zeros that way. I'm going to pause so I can pull up a machine. Well, I realized that my graphing calculator is at school, but I can show you, and I'm at home, but I can show you how I would do this on Desmos, and I'll make a separate video to show this portion on a calculator. So on Desmos, I'm going to graph the function that is the derivative, and I'm going to graph the horizontal line y equals 2. I'm trying to find out when is the slope equal to the derivative. And so this is, when is the slope equal to 2? So this is the derivative, which is equal to 2. And so I would see the intersection of those two items. This is a method that you're going to use on your graphing calculator a lot, where you're trying to find out where one function is equal to another, or where one function is equal to a number. And the easiest way to do that is by finding the intersection point. I'm going to go through the process for doing that on a calculator, though, too, because I know that that is not intuitive necessarily. So our answer would be 1.309. And I'll show you how to get that on a calculator as well. Okay, here's our last example today. This is asking you to find f prime of 2. And the reason I put this on here is because I really want you to get used to thinking, do I have to use the quotient rule? Because the quotient rule can get to be a lot. If you have something that can be simplified, I don't know if you've heard the expression, if it's a heart, break it apart, before you start taking a derivative, your life will be easier if you do simplify. So before I even take a derivative, I can see this function as x minus 1 over x, or even better, I can see this function as x minus x to the negative 1. And if I'm going to take the derivative and evaluate it at 2, it's really fast and easy to do it this way. Rather than deal with the quotient rule, I'm even doing it as I talk. So the derivative of x would be 1. The derivative of x to the negative 1 would be bring down the negative 1 and subtract 1. And now I can plug in 2, so f prime of 2 would be 1 plus 1 over 4, or 5/4. So be smart about stuff. Don't try to do the quotient rule if you don't have to. All right. Good luck tonight.